So what if we have two NOR? Two NORs mean you have two inputs to the NOR circuit. So we start from the NMOS first. Since this is two NOR, we have NMOS in parallel. And the source side of this two NOR should be connected to the ground. And then we have, because we start from NMOS here, the PMOS side should have the opposite of parallel. So you need to have the PMOS in series. Okay. The drain side should be connected to the output. Sometimes we call any value there, F or whatever. Then the VDD here connected to one side, and then the source of NMOS to the ground down here. Right, what about the input? The one of the input of PMOS should be connected to the one of the input of NMOS. So over here we just put it A, and then one of the input NMOS should be connected to the one of the input of the PMOS. So this is B. Right. So how to draw the stick diagram? First, maybe you can concentrate on the poly lines. For the PMOS, you have this poly in series, and then overlap with the diffusion, or we call it a P diffusion. Just put it with the green color. Just overlap of both. This one. Okay, this is a PMOS in series, and then we should draw the NMOS in parallel. So you have this one, and overlap the N diffusion on top of the polysilicon, and then we give the ground. If you look at here, this is the source side of the both NMOS, so you can put these two. Oops, sorry. I'll just draw first the VDD line, and then the ground line, and then the output line, so that you have a clear understanding on this. And then we have the ground connected to the source side of the NMOS. Put a contact. The X is the contact. And then you have a V out to the drain side. This is drain, this is drain, this is also drain. And the NMOS connected to both. So you have it like this, and then this one to here. And then in the middle part here, over here, it is connected. So you have it connected to this, and then to the ground, right, like this. So if you have two different metal layers, you have another contact on top of each other. And then if you look at here, we have A and B input. Then you need to connect that input. Maybe the first part here, go to this B, right? And this is A. And then another output here connected to this. And we have this as a B, something like this. So I think this is clear, right? But this is not optimized. You need to reduce the size. If you draw like this, you will take some space and area. So in order to optimize this, you need to rotate 90 degrees. Just rotate it. Maybe we start from the PMOS, the first one there. Rotate the polysilicon, becomes like this. Rotate the second polysilicon, becomes like this. And then we have the diffusion, the P diffusion. Rotate it, it becomes like this. And rotate that, becomes like this. And you also have the NMOS. You rotate the NMOS polysilicon. You have this and this. I just want to put it aligned to the PMOS. And then we have to rotate the N diffusion here and here, right? Okay, next we have a VDD connected to the PMOS, one side of that. Since we have the A of polysilicon is this one, and the B side is this one, then, oh, I shall not draw this part, difficult to see. Okay, then the blue color for metal, and this is A, this is B polysilicon, A and B. The A side here connected to the ground, so you have it like this, and this is the VDD. And then we have in the middle here, both are connected. This one, right? You just rotate 90 degree, and then the output should go, one of the output should go to the to the output metal. So this part is the output, and then the NMOS output should go both to the NMOS side. So if let's say you put it in the middle, then in the middle here, this is two connection, and this is the output. And then the ground is connected to the both here. Then you write down like this, and this is the ground. Okay, so all connected. So this is the 2 NOR. Looks like it is optimized, but still it shares some value here, like this one, 1, 2, and 3. So in order to optimize more, because now it has polysilicon 1, 2, 3, and 4, the red color here. So what should you do? You just to optimize this design, you just extend the PMOS, the polysilicon here, and then the N diffusion, you just merge both, so that you do not need to have this metal in between. Okay, I just remove this one, so no need to have that. You just connect it like this. Okay, so you have it like this, and then in the middle of the NMOS here, you can remove the contact here and here, so you will have to extend this part only. Okay, like this. So in the middle, you just connect only one. So instead of 2 in the previous, we have only 1 and 2 connection. We reduce the capacitance. Okay, this is improved, right? But if you look like this one, I think quite difficult to draw from this to this. By the way, how to write the function of these 2 NOR? Function is, you have the this is A and B. So since they are both in parallel, so you have A plus B. And they also have the PMOS side here, so you need to just invert this. So you have the full function of 2 NOR. Okay, so how to draw the stick diagram, a proper stick diagram, just by looking at this is a stick diagram, both are stick diagram, but if you want to make it faster, you just have a stick diagram of this is the VDD, this is the ground, and then you have the N diffusion, P diffusion first, and then N diffusion down here. Sorry, my handwriting. P diffusion, and then usually the output is method 1. Sorry, this is V out, and this VDD and ground usually method 2. Method 2. Remember our lecture last week, and this week we have the higher the method is, we connect it to the VDD and ground, right? So if you want to draw this, the polysilicon has 2, A and B, then you just draw like this. And then you have first, maybe looking from the ground first, go to both source of CMOS. So you have a metal connected to these two, so you can put it like this. This is one metal and metal, since different metal 2 and metal 1 here, so I just put a contact like this. And then we have both the drain side connected to the output. This is output, and you have this is the N diffusion side, and both should be connected to the V out, right? So you need to contact, put the contact in the middle. So this is the contact. Since over here we have the same types of metal, then you don't need to have a cross in the middle. Right, next we have the drain side of the PMOS connected to the output. So you can put, because this is a B, right? This is a B line here. You name it. This is A, this is B. Then one of that side, the B side here should be connected to the output. So since this is a B, should be connected to the output. So you just put a metal like this, right? And then you have the last part. This part already connected. A and B already connected using the what we call this diffusion, P diffusion. Then this source part here connected to the VDD. This is VDD, and this is the A side, right? This is A side, this is A, then should be connected to the VDD. So you just put the metal. Since both metal are different, then you put the contact. The cross here is a contact. So the overall is like this. Alright, what is the output? Output is the 2 NOR. 2 NOR. But what if you want to put to create a OR circuit, you just construct an inverter, right, on the right side. So what is an inverter? You can use, this is an inverter with the VDD and to the ground. So the supply coming from 2 NOR should be inputted to the inverter, and the output is the OR. So in order to do this, you need to have that VDD. Okay, and then since we have only one input to the gates here, this is the gate, then we just have one input. But like I said, this output here, output should be output of 2 NOR should be input to this one. So I will remove on the right side there this part, so that we have to extend this one up until here. Okay, like this. And then we have a VDD connected to the VDD here connected to the source. Okay, so you have it like this. And then I think better to put the other side, this side. Okay, VDD to the end diffusion, this part. And then we have the end diffusion connected to the output of, this is our output, the drain side, and this one connected also to this side, and you have this part connected, right? So this is your output. Is it clear? I hope so. Okay, so this is how we do it using the state diagram.